Welcome to the first Sustainable Jersey Tri-Shore Hub's public event. This program will be an introduction to the magical space heating and cooling device that is an electric heat pump. Our tagline is, you should never buy another air conditioner. Buy a heat pump instead. And we'll explain why this is the case. I'm Pat Miller, a member of the Monmouth Hub, Middletown Green Team, and Middletown for Clean Energy. And I'll be moderating tonight as we have several speakers. We plan to have all the speakers speak without interruption and have Q&A at the end. So if you're on Zoom, please type any questions or comments into the Q&A. And if you're on Facebook, you can just comment if you have a question. So I'm going to share one slide, and let me do that. There we go. This is New Jersey's overall emissions profile. New Jersey's energy master plan, which was released early this year, as well as the recently updated Global Warming Response Act and the governor's executive order, all put New Jersey on a path to zero net carbon emissions by 2050 and close to halfway there by 2035. So our focus tonight is on how do we get there. The answer is by electrifying our world and switching to renewable. The greatest emissions by far are from transportation, and you can see that at the top in the green band on the wheel at 46%. And that's the target of the EV legislation and incentives that the state has already passed. The next largest emissions sectors we need to reduce are residential, which is this red slice, and commercial down here, space heating. So that's the light green, at a total of 22%. And we seek to address this with a combination of heat pumps and energy efficiency measures. We'll also touch on reducing the third largest source, which is the 21% of electricity, or the aqua colored band, via solar or other renewable energy source. So all of this will happen over a number of years. We can easily switch now to renewable electricity, either by installing rooftop solar or switching to a clean third-party electricity supplier. We can also reduce our energy needs now by having a home energy audit, which may be done by New Jersey Clean Energy, and getting our homes sealed and better insulated. We can switch to an EV anytime we're ready to buy a new car and run it on our renewable electricity. The heat pumps are more likely to migrate in more slowly as our air conditioners or furnaces need to be replaced, which will likely be within the next couple of decades. So I'll stop sharing this now and let you know that personally, my husband and I have not yet moved to a heat pump for home space heating, but we did install a heat pump pool heater, and we switched to 100% clean electricity supplier, and we saved 10% by doing that, 10% off the cost. We took advantage of New Jersey Clean Energy's $49 home energy efficiency audit and sealed up our house to reduce our energy usage. We plug our Prius plug-in into our clean electricity, and we upgraded the home's electrical circuitry to accommodate the future heat pump, a second EV, and electric appliances such as hot water, stove, and dryer. So now let's move on to our first speaker, which will be Hap Haven from New Jersey Clean Energy Program, to explain just what a heat pump is and why they are so great. Please unmute yourself, Hap, and take it away.
All right, I think I'm, can you hear me?
Yes.
Excellent. Okay, my name is Hap Haven. I work for the New Jersey Clean Energy Program, and I'm so excited to talk to the hub tonight. You guys are the people, it's where it's happening. You're the early adopters, and the state is here to help you adopt heat pumps. And what I want to do is explain to you how our program can help you. So let's start with just a simple overview. The New Jersey Clean Energy Program handles about 11,000 applications every month. $11 million in incentives every month, the equivalent of 8,000 cars off the highway. So you see, we're one of the biggest programs in the country and nobody knows about us, right? So let's get with the program here and start using it. We have a goal of a sustainable future by 2050. And thank you, Pat, for mentioning that. It's really important that we all get on the boat here because we've got programs for the smallest house, like this log cabin in Medford Lakes, all the way up to the biggest hospitals. So we've got rebates for just about everyone in the entire state. And what I want to do is I want to give you a quick overview of the residential side, just so that everyone's totally on board with what you can get from the state. And remember, all the money in the clean energy program comes from you, right? If you pay gas, electric, or any utility, okay, it goes into a pot of money that comes back to you through these programs. Warm and Cool Advantage, the top left there, is basically for upgrading mechanicals. If you have an old dog of a heater and you want to do a 90 plus heater, 95% efficient heater, we've got a rebate for you. Home Performance with Energy Star, big difference. We do the mechanicals, yes, but we do the house first. So we air seal and insulate the house first, then we do mechanicals. Of course, if you're building a brand new house, we recommend that you build Energy Star Standard or Zero Energy Ready. And we're going to talk more about that as we go along. And of course, appliance rebates. We have lots of appliance rebates. If you want all the details, okay, go to our website, NewJerseyCleanEnergy.com, NJCleanEnergy.com. Click on the residential tab or commercial if you have a commercial establishment, and drill down in for all the rebates and all the information and the contractors nearest to you. All right, so let's continue with those incentives. If you're doing a high efficiency heater, we can give you up to $500. If you're doing a high efficiency water heater, we can do up to $950. If you're gonna do a cold climate heat pump, we'll give you $2,000 on the rebate. And we're gonna talk about that here in a few minutes I have with you. Now, above and beyond that though, you can add an additional $200 on the rebates if you are a moderate income customer. And that moderate income means, and I'll just round this out for you, a family of four earning less than $104,000. So that's a whole lot of people in New Jersey. And if you live in one of the urban enterprise zones, there's 37 of them around the state, you get also $200. So it's either or. So that's really useful. On the home performance side, which is, remember, dealing with the shell of the house first and then the mechanicals, I can give you up to $4,000 of a rebate, but more than that, I can give you up to $15,000, 0.99%, or up to $10,000, 0% financing. You see, New Jersey really has it going on here, and I would love to have you take advantage of it. Okay, so how do we get to carbon neutral or sustainable New Jersey, right? It's like all about high performance homes, high performance appliances, and alternative energy sources. And Pat just explained all of those to you. Pat, I'm in awe of the things that you've done. This is fantastic. Let's drill down on each one of these. Okay, high performance homes means one of two things. If you have an existing home, it's doing home performance, which I've already covered. We air seal, we insulate, then we do the mechanicals. And that's critical because we're still building homes like it's 1959. We're still building homes that are big and inefficient. Like this picture I'm showing you right there, okay, this is a $1 million home, okay, that looks like it's a Roman candle, right? That's how much energy it's losing. We can do better than that. And I decided today to show you this picture on the bottom. This is a house that was installed last week down in Maryland. It is a zero energy ready home, okay, and you can see it's being craned in. It's not built like a stick house out in the field where it gets muddy and dirty and wet. It was built in a factory and it was trucked to the site. Now, this is a very small one. Okay, this is like a 900 square foot home Okay, it's an affordable home similar to a Habitat for Humanity's builds, but it was put up in 6 hours with all the finishes and everything on the inside. They'll spend the next 2 weeks doing all the little things about it. But when we talk about high performance homes, we're talking about home performance, and we have money and rebates for you for that, and or zero energy ready or better. Okay, and we have money for you for that as well. Remember, I'm from New Jersey Clean Energy Program. We're the folks that help you take the right step. And along the way, when it comes to homes, we ask you to demand home performance testing, whether it's a home performance job or whether it's a brand new Energy Star home. You should have a blower door test, and you should be able to see, walk through with the energy auditor if it's a home performance with an infrared camera and see what your eyes can't see. Right? This is really, really important. There's all kinds of testing that gets done on home performance jobs and or brand new jobs. All right, let's keep going. High performance appliances. This means that what you do is you buy, when you go to replace an appliance, the most energy efficient household appliance to lower your plug load. Okay, that is how much electricity or gas you're using year round, right? But plug load is specific to electricity. Whoops. Excuse me, it just wants to advance all by itself there. All right, so, and the thing to know about Energy Star is that you should be buying the most efficient you can afford. Energy Star, okay, is a level, 15% better than the average market. But within that, I can go 20%, 30%, 40%. I can buy appliances that are significantly better than just being Energy Star rated. So go to the Energy Star website and find the product that you're looking for, and then compare, because there's more out there that you can do. Okay, cold climate heat pumps. This is where the rubber meets the road for this program. And if you have a single zone cold climate heat pump, whether it's ducted or ductless, I can give you up to $1,000. All right, and I'm going to talk about the multi-zone in a second. But let's say you had an electric house and you had one zone, the whole house, but it's a small house, and I'm going to put in two of these, one for the first floor, one for the second floor on a small house. You'd get $2,000. So that's really important. But hold up. Let's be clear on what a heat pump is. It's not combustion, okay? And it uses simple physical laws that things heat up when they get squished, okay? When we compress anything, it heats up. And something else that it takes advantage of, the physical law that heat moves from hot to cold, okay? So here we go. In the summertime, the heat gets squished on the inside and it gets dumped to the outside. Actually, it's picked up from the inside, sent to the outside, squished to make it hot, so then it moves to the outside. During the wintertime, we're squishing on the outside, compressing it on the outside, and bringing it inside, and then letting the heat radiate or be blown around the house on the inside. So all it's doing, it's exactly what its name is. It's a pump. It moves the heat from the inside to the outside and back and forth. All right, last couple slides here. Here is the thing that's being used more than anything else right now in our program, a multi-zone cold climate air source heat pump. Now, heat pumps, there's lots of heat pumps out there, but cold climate heat pumps are what you want, because regular heat pumps lose efficiency as the temperature gets colder and colder. A cold climate heat pump will hold its efficiency all the way down to like -4, -10 degrees, perfect for our state. And if you use two of these, one compressor on the outside, 3 zones, that's what I'm showing you on the picture here, 3 zones on the inside, and you pick 2 of those to do your house, I could give you 2 times $2,000 or $4,000 in rebate, plus any bonus rebates that you get. All right, so this is really important to understand that not all heat pumps are created equal. And when it comes to the rebate, if you want the big time rebate, you're gonna have to buy the most efficient heat pump, which is called a cold climate heat pump. And if you look at the bottom of the picture on the right, it says NEEP cold climate heat pump list. If you Google that or search for that online, you'll get the list of every manufacturer and every model of heat pumps that qualify in this program. All right. Another game changer for us is a heat pump water heater. Heat pump water heater, remember it squishes stuff, right? So it takes the air from the basement, squishes it so they can transfer it into the tank of water, and then blows the cooler air into the basement. And that's what I'm showing you there in the blue arrow on the bottom. It can blow the cool air into the basement, cool, dry air in the summertime. That's great. What about the wintertime? You can put a Y on the duct and blow it to the outside. So all kinds of ways of taking advantage of heat pumps. All right. Last thing on the list is just what are we doing for alternative energy sources? And Pat already talked about a bunch of them. You know, solar electric obviously is one. Solar thermal is still an option. That's my evacuated tube solar collector. I live in Pennsylvania. Okay. And I don't have a PV system, but I've got an evacuated tube. Okay. And from, let's say, somewhere in the neighborhood of May all the way through the end of October, I just use that. I don't need to use anything else. In the wintertime, I have an electric backup. So still an option and still solar credits. But here is the big one on the horizon, and that is fuel cells. About 10 years ago, I looked at doing fuel cells in my house, but the only people that were doing them were Amazon and Google, big commercial industrial outlets. Well, they've been able to, crunch the size and increase the power, and now they're putting them in cars. Toyota, Hyundai. Okay, there's a lot of cars on the road in California. Okay, and it's getting ready to come to your house sometime soon. And just so you understand, there's three kinds of hydrogen: gray, blue, and green. Okay, and that's called like blue gas, green gas. Okay, it's talking about hydrogen. Gray gas is where you use natural gas and you strip off the hydrogen and you end up having carbon go into the atmosphere. Blue gas is where you use natural gas or something, it's similar to it, but could be propane, but natural gas usually. And you strip off the hydrogen, but you save the carbon. And green hydrogen is all about getting the hydrogen from renewable sources. So that's it, Pat. For me, it's like we've got lots of money to help your people, the great people in the state of New Jersey. Okay, but we need you to take advantage of the program. Please go online to our website, njcleanenergy.com, and let's move New Jersey into the future. There you go, Pat.
Okay, that's great. Thank you so much, Hap. That was a really good description, and also all those incentives make me want to go out and buy that heat pump right now. Okay, so our next speaker will be Dr. David Ho. Actually, I'm not sure if he's really a doctor himself, but he's Dr. Energy Saver. And he's going to talk about the complete home heat pump solutions from the point of view of his company. And of course, these complete solutions include the energy audit, the air sealing, the insulation, and so on. So I'll let him talk about that. And David, you're going to have to unmute yourself. Okay. And if you have slides to share, go ahead and do it.
I'm sorry, I don't have a presentation. I'm going to kind of wing this.
Okay.
My name's Dave Ho. My company.
Can you stop sharing? I think you're still controlling the screen. Up at the top, does it say stop sharing?
Yeah, it says, yeah, there you go.
Up at the tippy top, there's a green bar and there should be a button that says stop sharing.
The very, very top.
PowerPoint, but put your cursor over the very top of your monitor. Just put it all the way up at the top of your monitor.
There you go. Okay, thank you. All right, David.
Sorry, I was having a problem there. It was at the bottom of my monitor.
Oh. Okay. All right. Thank you. All right. David, the floor is yours now,
Okay, should I share my screen as well?
if you want to.
Oh, let's not do that. Okay, my name is Dave Ho. My company is called Home Comfort and Energy Experts. I do participate in the New Jersey Clean Energy Program, and I'll just kind of give you a brief background of who we are and what we do. I have a long background in HVAC. And
David,
many years ago when
excuse
HVAC.
me, David.
Yes.
Maybe you should stop sharing unless you have your own slides. I think that'd be better. Now we can see you. Okay, thank
Anyway,
you.
so I have a 30-year background in HVAC, and I'm going to say somewhere around the late 1990s or early 2000s, equipment started becoming more sophisticated. Heating and cooling manufacturers produced things with new refrigerants, new and theoretically environmentally friendly refrigerants, multiple stage heating and cooling, variable speed, modulating capacities. And as a high performance company, we gravitated towards those. But when we started installing them as your standard HVAC contractor, what we found is that half the times they were not getting the efficiency that we claimed or the manufacturers claimed. So we started looking at the building envelope at that point, and that was a real eye opener for us. The building envelopes in all the existing housing stocks in New Jersey, I think there's 3.2 million homes. The vast majority are built before the 70s. So in order for us to deliver better results for customers, we started combining high efficiency equipment with fixing the building envelope, which is what Hap mentioned before. That's basically air sealing, insulating. If there's distribution systems, whether it be ducts in attics, ducts in crawl spaces, or hydronic piping in unconditioned spaces, we started treating those areas. And for us, a light bulb went off because the results customers got were so spectacular. We realized that was the way to go. So as time evolved, we started having customers ask for different types of heating and cooling, heat pumps being one of them. And a heat pump, I'm not going to get into the real technical details because I think there's other speakers, but the ductless split heat pumps are really phenomenal. Rather than using, fossil fuels or electric resistance heat, you're using electricity just to drive a small compressor. In most cases, it's drawing 14, 15 amps of electric. And it's using the refrigeration process to extract heat from outside air and deliver it inside the house, and vice versa for cooling in the summer. And we personally, I had heat pumps in a very old home in Shark River Hills, New Jersey for almost 20 years. And they were not rated as the cold weather heat pumps, but as a technical kind of geek, I would check these units, and in the midst of nor'easters in the dead of winter, they were still delivering 105, 110 degree air, which is very similar output in temperature to a high efficiency furnace. So they work phenomenally. They've gotten so much better now with the cold weather heat pumps. But what we believe is that because most houses lose 40 to 60% of the air you're paying to heat and cool through excessive air leakage, we really believe that we should seal up those building envelopes. And I think I've probably done well over 500, 600 New Jersey Clean Energy Program jobs. And the amount of BTUs we're saving just by sealing small cracks, gaps, and holes in attics and in crawl spaces and things like that, reduce the amount of BTUs we consume, which is one of the things we need to focus on your first slide, Pat, was that residential slice, reducing energy consumption there. So most people contact me to solve comfort or indoor air quality problems. But when we meet them, we take them through the New Jersey Clean Energy Program. Hap touched on the great incentives when you do as a whole house approach, meaning you upgrade your insulation, you air seal the house, you upgrade mechanicals. And if some people aren't ready to go to all heat pumps, because that's kind of a big step, there's hybrid systems, a high efficiency furnace with the heat pump attached. So I can use electric heat for the majority of the year. And when it gets bitterly cold, you can transition to very high efficiency natural gas. There's many things you can do. And what I would suggest for anybody that's on the hub here this evening is that when you're starting to do your research, definitely look at the clean energy program, look at a whole house approach before you put in a high efficiency heat pump without looking at the building and at least evaluating it. We've been out to a lot of houses where people put on solar panels. And that's great. I love solar panels. They can do an awful lot, but we go into an attic and find there's 2 or 3 inches of 1955 vintage insulation, and the house is just in the air conditioning mode. It's just consuming way too much energy. So by focusing on the building envelope, in addition to heat pump type technology, you can get the biggest bang for your buck. So that's kind of what we do. As far as the heat pumps, Hap alluded to, there's many different designs. They're called ductless heat pumps, which means you have an outdoor unit. You typically have an indoor head that hangs on a wall. They're extremely quiet. They distribute air beautifully. There's also multi-zone, so you can have one outdoor unit, multiple indoor units for different areas. And in fact, they call them ductless, but they do have some concealed type units. I'll give you an example. In my old house, I had it's called a ductless heat pump, but there was a small concealed air handler that fed air to 2 bedrooms. So there's a lot of ways to do it. The energy consumption of those units is very, very light compared to standard whole house air conditioning. And if you have a small solar array, you can drive these units with those typically. I think though, it definitely, when you do it, it pays to do your research on the different types, like the cold weather. Also do your research on the folks that you might hire to put it in. They're not overly complicated, but you should have somebody with experience or that can do the research to put them in correctly. Because like anything else, if it's put in correctly, it's going to work. It's going to function as you expect as the consumer. And it's going to have a very, very long life. I mean, I sold my house and they were there for, I think I said 20 years with 0 problems. So we really enjoyed them. It took a little bit of getting used to. Some of the pitfalls that I experienced because I was a little bit overzealous was I pulled out an old gas fired furnace, put in all heat pumps, because at that time electricity was 11 cents a kilowatt hour, gas was $1.54. Now it's reversed a little bit. But I took all the heat out of my basement and then realized I had cold floors. So what I ended up doing was putting another head for my heat pump in the basement to take the chill off of hardwood floors. But after that, I raised a couple kids in the house. We also had, I didn't have a heat pump hot water heater. We've seen them, we've used them. So I had a high efficiency on demand, which is very, very efficient compared to standard water heaters for sure. And where we have used the heat pumps that have been a real lifesaver for some customers is we have big retirement communities in New Jersey that they're older, they have all electric resistance heat. So in those applications, rather than destroying the house and gutting them to do all this work, we abandon the electric heat, we leave it in place, and we put in, air source heat pumps, and it heats the house beautifully, and it cuts the bills dramatically. Some of these people in small little 1,200 square foot ranches, we're paying $500-600 a month for heating, which is just not sustainable for somebody on a fixed income. You go to a heat pump and then it becomes much more manageable. And then you also have high efficiency air conditioning in the summer. So that's really about it for me. There's a lot of other progressive contractors out like us. If the consumer should do their research, talk to a few people so you can get a feel for what's out there. And one of the other great things that Hap didn't say, when you go through the clean energy program, New Jersey by far has the most robust incentive program in the nation. That also comes with a lot of checks and balances for consumers. Because when you go through the clean energy program, you're not dealing with, a contractor down the street. You're dealing with somebody that is accredited, has certified people on staff. It's hard to get into the program, but once you're in, that means your quality of work has to come up. In the event there's ever an issue, the clean energy program also has certain standards. They audit us, we audit our jobs, and it just goes down a hill. But the moral of that story is the quality control is substantially higher going through the clean energy program for these types of large projects. And we have done many projects that people have taken full advantage of 4,000 cash back, financing them up to the 15,000 at 0.99% for 10 years. So in a perfect world for us as a program contractor, when we do these jobs, the energy savings that we produce by upgrading the equipment, by taking care of the building envelope, if the customer uses that financing, the energy savings we produce offsets that, and the project literally pays for itself. So in addition to going a long way towards getting to zero carbon by 2050, you're much more comfortable. Your indoor air quality improves dramatically when you seal up a house properly. We could spend another whole day just talking about that alone. But I think it's a win-win, looking at this technology, being a little progressive, and then also using this great program in New Jersey. So Pat, that's about all I have, unless somebody has questions.
Okay, that's great. Now we know where to come.
David,
Okay.
David, I'm really happy you mentioned that, because we inspect about 10% of all the work done in New Jersey.
Yeah.
And so it's a really key thing that you brought up. Thank you.
Health and safety, I didn't touch on that. Health and safety for people that are working and fixing, upgrading, retrofitting existing housing stock. You can have a house that's been no issues for 50 years. Somebody comes in and monkeys around and does some insulation, changes a furnace, and all of a sudden there's problems. So just the knowledge and the whole house approach and the health and safety checks that we do as part of this program is very advantageous.
Okay, thank you so much. And we'll go on to our next speaker, who is Paul Rainier. And I believe he's a member of the Monmouth Hub, although you'll have to confirm that or deny it and tell us what town you're in. But he's a member of our Sustainable Jersey Hubs.
Yeah, hi, good evening, everybody. Thanks for the invite. I am on the Aberdeen Green Team, which hasn't been meeting in a while, but I'm still there. I chair the Aberdeen Environmental Board too. So that's what town I'm in. So I was asked to speak about this project I took on with my house here in Aberdeen. I lived in this house for 61 years, all my life. I've never moved. My parents built this house in 1959 when my mom was pregnant with me. It's a single story. It's now a 1,500 square foot house. It started off smaller than that. 2 rooms were added on. Both the add-on rooms have poured concrete floors. The rest of the house is accessible underneath through a crawl space. There's no real accessible attic space. Okay. So what I have dealt with when I decided to do some energy upgrades to this house was to echo what David said. Lots of air leaks, lots of bad insulation, a furnace. It's got hot water baseboard, oil heat. I'm in a section of town that does not have natural gas. It does not have sewers, and there's no plans to get those to us. I'm also in a forested area. Solar is out of the question at my house. What I was dealing with at first was the air conditioner system we had was an old Sears 18,000 BTU through the wall unit in the living room that the bearing had worn out and it was so loud you couldn't watch the TV. And a couple other little air conditionings in the bedrooms. And again, an oil boiler that was 50 years old and had sprung a few leaks in the actual tank, and it was just patched together, so all this stuff, it was due to be replaced. I started out just looking, to replace the air conditioner, take the through the wall unit out, seal up the hole, and get something that was quieter. So I started doing some research, and this was back in May 2008. Okay, and I came across, I think the mini split inverter air source heat pumps were pretty new technology back then. I don't know how new, but the cold what you call the cold climate models weren't really that available at that time. So I wound up getting, you know, what was available. I bought a Sanyo units. I actually bought 2 outdoor units and 5 indoor units. You know, 1 indoor unit for each bedroom connected to one of the outdoor units, and then 2 larger indoor units, 1 for the living room, 1 for the rec room, connected to the other outdoor unit. And I was doing a lot of research online and whatnot. I had been to a few workshops. I had been to something at Rutgers where we went to a house up there and used blower doors and stuff to check for air leaks. So I decided, you know, I know my house has air leaks. I could probably make my own blower door, which I did with a box fan and some duct tape and some garbage bags. And one of the things I learned, you know, up there, they told me, so I was aware of it, is close your fireplace damper before you suck air out of your house, because you might suck ashes in. So I did that. And yeah, as soon as you hook up a fan like that and suck the air out of your house, you can go around and with your hand and feel where all the air is coming in, you know, along the windows, you know, through crazy places where you wouldn't think, like the electrical outlets. It comes through there. It comes through any little hole. So I went around sealing all this stuff and whatnot. Insulation, I had a couple holes in my attic where there were vents where I was able to remove those and have insulation blown in. That's something I paid for. I didn't feel like handling that stuff. My background is I was an auto mechanic for a lot of years, so I was comfortable doing air conditioning work in automotive environment. And, you know, that in some ways is a harsher environment than a home, because the cars are moving all the time and hitting bumps. You know, you get a lot of leaks in those systems. If you're, you know, if you know how to do your own plumbing, your own electrical, your own carpentry, and can follow instructions really well, pay attention to detail and don't cut corners, you can probably do the system yourself like I decided to. My main driver was I like to do things myself because I think, you know, I can get them exactly the way I want them. There's certain things when I chicken out on and I call professionals in for sure. If you're not confident at all with any of this stuff, please call a professional, somebody like David or somebody. Again, you know, I was pretty confident in it. So I wound up, you know, reading a lot online about, you know, how do you size these things, right? So all different sizes, BTUs. So I wound up trying the software approach, which worked really well for me. I tried a few different software packages. There's one I settled on called HVAC Calc, and I settled on it because it wasn't very expensive and it was pretty easy to use. And basically you load it up on your computer and you draw your house on a screen. You go around and measure all the rooms, measure everything. You draw it to scale on the screen. You tell it what kind of materials the walls are, you know, how much insulation or value you got in there, where the windows are, what kind of floors you got, what kind of insulation you got in your attic and whatnot. And it attempts to give you an estimate of like the heat loss through your house and whatnot. And what I found was a couple things. I found that my house really, for, you know, I could get away with a 65,000 BTU furnace. So I was sized this for the boiler at the time. And I also found some places where in my house that could really benefit from some insulation. One was the crawl space. The crawl space was not insulated, and the software was kind of cool because I could flick in like the idea that, okay, I insulated the crawl space. How much better is it? And it was like a big net gain by insulating the crawl space. A couple other places where I had significant heat loss were the poured cement floors in the 2 add-on rooms. So I wound up putting rigid foam over those, and then strand board, and then engineered floor on top of those to give them some insulation value. So I wound up installing the heat pumps. Pretty straightforward, like David was saying, you know, mount the outside units up off the ground, you know, high enough so the snow doesn't get in the blades. Run the tubing and the electrical and the drain through the walls to the indoor units, and, you know, hook them up. The really cool part I thought was really cool is the refrigerant's already in the units. That was nice. Not what I was used to in the automotive field. You need special tools for this stuff, right? You need a vacuum pump, you need gauges, you need leak down testing, you need nitrogen tanks for pressure testing. I got all that stuff. So I'm going to tell you the parts for the 5 indoor units and 2 outdoor units cost me $8,500 in May $2,008, and the tools cost me another $300. That was for the air conditioner heat pumps. And the interesting thing, I started off just going for air conditioning, and the guy said, why don't you get the heat pumps? They're only a little bit more, you can get heat in the winter. I said, yeah, okay, let's do that. and I've never regretted it. To this day, of all the things I've purchased, this is probably the thing that I'm the happiest I purchased, is these mini split heat pump systems. Like somebody else was saying, they're quiet as can be. You know, since I have one in each bedroom, the people can control their temperatures individually. The only problem I've ever had was, and they've been in operation 12 years now. So I had one of the indoor units develop a squeaky motor on the blower fan, and it was easy enough to purchase a motor and just replace that. As for the boiler, I wound up, I couldn't get off oil. I needed oil, and like somebody else was saying, I like warm floors too, so I didn't want to get away from the baseboard. I wound up getting a Buderus German-made computer control. I bought the most efficient thing I could at the time. I wound up having to line my chimney because the stack temperatures out of this thing were so much lower than the old boiler I had. So I had to line the chimney so it wouldn't condense inside and corrode my bricks apart. And that's been working really well too. So I can tell you, my only, you know, I'm working on a second house now. I have a house in New York State that's got a way more air leak problem than this one had. And it's got foundation issues and whatnot. But now, you know, I'm looking at the cold climate heat pumps because it gets significantly colder up there. It's up in the mountains. Like somebody was saying, the ones here I have that aren't cold climate rated, when it gets to 0 degrees, they're pretty much, that's it. You're not getting anything out of them at that temperature. In fact, when it's like 25 out, they're really struggling, these ones in Aberdeen that I have. And again, these are like the older first generation. They're not the cold rated ones. So I do need the backup heat source in my Aberdeen house, the oil boiler. I can say that my electric bill, everything, I don't know what portion is attributed to the heat pumps themselves, but my electric bill never exceeds 400 kilowatt hours a month. And the combination of the heat pump installation and the new boiler dropped my fuel oil usage in half for the year. I used to purchase 275 gallon tanks of fuel oil. I'm down to 1. It would be great to be able to not burn any fuel oil at all. Maybe I'll get there someday. For now, for the electricity, I was able to purchase 100% green net electricity, you know, through an alternative supplier. And like Pat was saying, that actually costs a little less than what JCP&L wanted to sell me straight up. So I guess that's about it. That's my experience with this. Again, I love the idea that, you know, of making buildings more efficient. It's great that this is catched on because there is just so much opportunity to improve the housing stock out there. So thank you. You're muted, Pat.
Okay, thank you, Paul. That was really a great description of what you've done, and it's really interesting. Okay, our next speaker is Phyllis Garr, and Phyllis is also a member of the Monmouth Hub and of the Marlborough Green Team. And Phyllis has been doing this for a very long time too. I don't know, she might be in competition with Paul for how long she's known about these things and what she's been doing. But she has several features in her home, including heat pump and solar panels. So Phyllis, why don't you share the screen, and your mute is already off, and take it away.
I'd love to. I just wanted to mention today that we had someone like you come in and do an audit, and we did a lot of insulating and a lot of little things that they suggested afterwards. It was very helpful. Actually, what I'm going to speak about is back in January of 2006, we had a smoke puff. I don't know if you know what a smoke puff is. I woke up at 4 a.m. on a Sunday morning in the middle of January, and outside our bedroom door, there was black smoke. Now, our room is the furthest from the furnace, and we're in a pretty long 4-bedroom ranch. So I went exploring, I thought, to try and find out where the smoke is coming from. Well, I went a little ways, it got stronger and stronger. I quick turned around, came back. I woke up my husband, we threw clothes on, called 911 and got out of there. They didn't let us back in there for 4 days. And then there was a lot of damage. What actually had happened was the oil furnace, it did something, it just didn't work right. And because of that, the smoke backed up in the house. It malfunctioned, they said. And they also told us that they could put Band-Aids on it to get us through the winter. But by September, we needed a new oil burner. Well, when they left the house, I said to my husband, there's no way I'm getting another oil burner, and I don't want natural gas either. So he said, if you can find something else, fine with me. So I started my research. And I came up with the heat pump. And heat pumps at that time were just about non-existent in New Jersey. So I read the literature, I called the company, I spoke to 2 different men who I spoke to for an hour and a half to 2 hours. And I was pretty convinced that a heat pump was the way to go. Now I'd like to, would you please bring up the heat pump? Steve? This was our first heat pump. It's outside, it's on the slab of the air conditioner, which had been extended a little. And this is where the air comes in. And that's what other people were talking about before. And next, I'd like to show you the inside part. This is the inside part of your unit. And this is what blows the hot air, or in summer, the cool air throughout the house. Now, we had something in the oil burner that took care of hot water. So we needed a new hot water something. We needed some kind of a heater. And we bought a high efficiency water heater. At that time, they didn't have any connected to heat pumps. But this has really been pretty amazing. It keeps the heat in, the cold out. We have never, in the 14 years I've had it, had any problems with it. About the same time, I'm sorry, I'm going to go back. I had asked before I started this, before we actually bought one, I asked to speak to some people about heat pumps because we really didn't know anybody that had a heat pump. So I spoke to a man in Maine, and he told me that he and his father-in-law had the same house. His father had oil and he had a heat pump. And it cost him exactly half that it cost his father-in-law to heat the house last winter. Or when I say last winter, I'm talking about 2005, because this was in 2006 that I was doing the research. Then I spoke to a man in Oregon, and he had natural gas. And he said that it cost him 2/3 with the heat pump of what he paid for natural gas. Well, I was pretty sold on this, and that's how we really came to start having the heat pump. We bought it, and as I said, at the same time, we got the water heater and we also got solar. Wasn't really planned that we were going to get solar at this time, but we had been waiting 1.5 years for subsidy to come through from New Jersey. And it just happened to come through when we were putting in the heat pump. We've just shown the 2 panels, the 2 sides of the house that have the panels. These are the original ones. In 2011, I got another system that's on the third side of my roof. Now, next we're going to show you the inverters, because the inverters, they're the three that say Aura, and they take the energy from the sun and they make it so that you can use it in your house. Today, I have 5 of them in my house because I have the 2 systems. There were many things, I'm sorry, I'm skipping around a little. There were many things that I noticed when I got both the heat pump and the solar panels. The first thing I noticed was I only had to dust the house every other week instead of every week. It was so clean. Everything was quiet, both the heat pump and the solar. You didn't hear them. I had no regular maintenance with either one. And if you wanted to turn the heat up with the heat pump, it heated very quickly. And with air conditioning, it cooled very quickly. My daughter also happened to get a heat pump a few years after we did. And she got it in the middle of the summer. And she called me up about a month after she got it. And she said, "Mom, I can't believe it. My electric bill went down $100. And that's it. All of these together are very economical. Now, with your solar, if you don't use it all when you're producing it, what you don't use goes back to, in my case, JCP&L. They have like a bank account there. They use the energy that they take back from you, but then they record it and it mounts up. And when you need the energy for, say, heating in October, November, December, January, you just take it from that bank account so you're not paying for it. I've never had any maintenance on my solar. And the Board of Public Utilities awards you an SRAC for every 1,000 kilowatts of energy that you produce. SRACs are solar renewable energy certificates, and you sell them to companies. It works a lot like the stock exchange. You go to a broker or you call them, and they find companies that need to buy some, and the state has mandated that certain companies, electric companies and certain others, have to buy a certain amount of SRACs. Now, if they don't buy it, then they're subject to a fine from the state of New Jersey. The SRACs are sold for slightly less than what the fine would be, so it pays them to buy the SRACs, and that's one of the ways you get paid also. Another thing that we have are the solar tunnels. For dark rooms, this doesn't produce energy, but it saves energy. We had a whole entrance hallway that was very dark and a bathroom that had no windows in it. Every time you went in, you had to flip on the light. The little dome in this picture here, is where the light comes in to the solar tunnel. All the light comes in there and it goes through a tube. And that tube is like a very shiny, bright metal. And it reflects the light all the way down to this, it looks like a fixture in your room. This is in our entrance hallway. And we have the exact same thing in our bathroom. It is very bright. And except at night, when it snows or when it rains, you don't need a light in these areas. Now I'd like to show you my electric car. This is an all-electric car, and that little red thing that you see in back on the side, that's where you charge the car. And I have a charger in my garage, and I charge my car all the time there. The only time I don't charge it there, and of course, that uses electricity that comes from the sun. And the only time I don't use that is when we go on a long trip. But one thing I know a lot of people are worried about with EVs is how are you going to, when you're on a trip, how do you find a place to charge your car? Well, my car is a computer. And if you want to find a place, you just put your finger on a dot and on the left-hand side of your screen, and it has a computer screen rather than a dashboard. It comes up and it tells you all the different electric charging stations, where they are. They're always near food, so you can go in and buy a meal while the car is charging. And they're all superchargers, so you can get a half a charge in about 20 minutes. My solar panels actually are, they're taking care of, and they are giving the energy for my electricity, for lighting. All of my appliances are the Energy Star appliances, and they're all electric. My water heater, my car, and this past year, for all of the electricity that was used, it cost me for the whole year from the end of October to the end of this October, $922.08. My solar arrays, and this includes both the first system and the second system, together cost me $54,000. I've received so far $54,887 from the sale of SRACs. And if there's anybody that would like to know more about this, I would be happy to talk to them. Thank you.
Thank you, Phyllis. That was fascinating. Steve, are you taking the questions? Because I've been noticing that they keep disappearing.
Yeah, I think several of us are answering the questions. We're back down to about 2, still open. Let me just raise it. So Seth is asking, he's using a heat pump now. What type of air filter should I use in my house? Does anybody
So
have an answer?
That's an open question.
Yes, it is.
Okay, so let me just talk to that. The key thing about heating systems that use forced hot air and air filters is that they have to work within certain pressure parameters. And so what we see nowadays, especially with COVID, is people saying, oh, you should put in high efficiency heaters. I mean, filters. if you just do that without doing the proper measurements or understanding the parameters for your heater, what you can do is force your heater to do something called cycling off the limit, which means that it gets too hot in the heating mode and gets too cold in the cooling mode. And so what ends up happening is you choke the heater, and the heater becomes extremely inefficient because it's ramping up and then down and then up and down and up and down. So nowadays, okay, I would recommend, the something called a MERV 13 unit, and that is the lowest unit that you can filter viruses with. But you can't go out and buy a MERV 13 filter in a store and stick it into every unit, because you're going to do what I just explained. So you have to have a heating, contractor, or someone like Paul, come out, or David come out, who understand how these things work, and do pressure testing on your heating so you know what you can actually use. Okay, that's a key thing. And frankly, it's a problem that heating contractors run into all the time, because in our industry, we ask contractors all the time, heating contractors, that's HVAC contractors, people who are blowing heat into your house, what's the single thing that you do the most of? And the answer to that is, we move air. And this is to the heating contractor. What's the single thing you never do? And the answer to that is measure air. Remember in my presentation, I said that you should demand testing. When you have a heating contractor come out, it's like they can provide all the testing that you need to be able to show you everything. Right? I'm a big proponent of that. So anyway, I hope that answered the question.
Thank you. One final question is from Jessica. What special considerations are there for those of us in multi-family buildings like condos and townhomes, etc.?
Well, for us, I mean, we have a multifamily, program. So in terms of rebates, there's a good chance that we have a rebate for you. Find a contractor that works in our program. You can get an answer to that, or go to the website and get an answer to that. But when it comes to multifamily buildings like condos, if you have your own individual heating unit, which most condos do, right, you can do a lot of stuff. I mean, you can replace your existing heater with a heat pump. You can upgrade it in one of many, many different ways. So there's lots of things that you can do if you, we're talking about owning your own house, but just in a multifamily kind of situation.
So basically the landlord the owner of the building needs to do the contracting to get the work done.
Well, it depends on if you're talking landlord, you're talking renting. When I see condos and townhouses, I'm thinking that these are individually owned.
Oh, I see.
Right. However, okay, most condos or townhomes are in an association. They have some sort of association to run the group of buildings, and sometimes they have issues with units and size of units and penetrations. One of the biggest problems that we find is that if you have an old like 80 plus gas heater and you have a chimney and you go to a 95% efficient heater where you no longer use the chimney but vent to the outside and draw supply air into the unit from the outside, some condo associations don't let you make that penetration. Right. So you're going to have to, if you belong to an association, you're going to have to find out what their bylaws say about, how you can, where you can put utilities, and, can you put the compressor on the outside? What, all those different factors.
All right. Thank you.
Right.
I think that would have answered the question that Jessica had.
Are there any, I thought maybe some of the questions that you answered would be of general interest. Are there any that you want to talk about?
Well, there's a lot of questions that came across that, I think I hit reply, so everyone saw the answers to the individual questions. I hope that happened. As opposed to the individual person, because they're all really good questions. I wanted to say something to Paul though, because Paul, if you were doing what you did so long ago, if you were doing it now, it would be a snap. You would be so super happy to do it now, because there's manufacturers like a company called Mr. Cool that is low cost and geared exactly for the do-it-yourself, community out there. And they have special fittings, so and line lengths that are just for DIYers, and you don't need special tools or anything. You just basically hook it up, and turn it on, so you can go that direction. I really applaud you for all the work that you did.
That's really good to know, because I am going to shop for another system soon for a different house. I was not aware of that. Right. I had to use a flare tool and, oil and torque wrenches and that kind of thing to
Yeah,
connect.
and you had to evacuate with the nitrogen. You were saying you
Yeah.
bought a nitrogen tank, and yeah, so there's a lot of tools and everything. But nowadays there's units for DIYers. But I don't know if those would qualify as a cold climate heat pump. But you can find out real easy because of that one thing I put up on the board there. If you go to NEEP, is an acronym for Northeast Energy Efficiency Partnerships. Okay, and so, but if you just typed in NEEP cold climate heat pump list, you get to it. You could put in whatever manufacturer you're talking about.
That's great. Hey, I wanted to add one more thing I forgot to talk about. And one more thing I did to my house that had an unexpected side effect, right? Because I do have a crawl space and I was losing heat through that. And I decided at one point to call an insulation company and have them blow in closed cell insulation, right? So this is stuff, they have to wait till the humidity is really low in your crawl space so it sticks, but it sticks to everything. They basically blow like 4 inches of this stuff up underneath, sticks to all the wood, all the pipes and everything. So you better have all your wires in place. But so I did this to, keep the floors warmer, and it did that. But the side effect I didn't expect, apparently, is it completely sealed the air off from the crawl space from coming into the living quarters, right? And my mom at the time, had respiratory illness and would periodically get sick. So did I. And by sealing off the air from the crawl space, our illnesses just sort of disappeared. It was like, whatever was growing down there, mold, fungus, whatever, those vapors were creeping up through that. And that sealing actually had a health effect.
And that's something that David was talking about. One of the things that David is a home performance contractor in the state of New Jersey, and everyone has to go through certification for that. And one of the things you learn about are the health effects, okay, of air sealing and insulation, the benefits of it. So I'm really happy to hear that story. And I'm so envious of Phyllis. Phyllis, you did so much on your house. That's really, really exciting.
It was.
And I swear you probably generate enough power that you could power half of Manhattan.
Well, not exactly. But
Well,
I'd like to thank Steve for showing the pictures for me.
Yes, Phyllis is an early adopter.
Yeah, and I forgot to introduce Steve, who is my husband, Steve Miller.
I have a general question. The Q&A was very useful with 13 answered questions. And for people who see that, the Q&A, they can open up each and see the answers. They seem to collapse by themselves, but if you open them, you can see the answers. And they are very good answers.
Yeah, I didn't see them coming through, and now I see what you have to do is go to where it says answered, and that's a tab.
Yes.
And then you can scroll down, but you have to also hit where it says show all. You have to hit that to see the answer.
So I posted in the chat, as well as I answered Susan's question if you go into the Q&A under answered, she had asked about whether we're recording this and where we'll be able to find the recording. And there's a couple of different places where you'll, give us a few days, but it'll be posted on the Sustainable Jersey website on the webinars page, past webinars. The Atlantic Cape May Hub has a YouTube page. They'll post it there. You'll be able to watch the recorded live stream on the Red Bank Environmental Commission Facebook page. And if you're part of one of the 3 hubs along the Jersey Shore, the Monmouth, Ocean or Atlantic Cape May hubs, they'll post the recording in their Basecamp projects as well.
Hey, Lauren, I just posted in the chat my email address. I never do this in public scenarios, but I'll do it for Sustainable New Jersey folks, right? So if anybody has any questions, it's hap.haven@njcleanenergy, and I think I posted it to all parties.
You did. Oh, no, you did it to all panelists.
Okay, how do I do it to all parties?
Choose all panelists and attendees in the little drop down.
Ah, okay.
So
So-
Phyllis also just wanted to mention in the chat, you're getting some love. Mike Winka, who's a former BPU employee, also a big Mercer County hub participant, he said you should be presenting to all of the hubs. You have the best presentation of stuff that he's seen in terms of reducing household carbon load, you know, all those kinds of things. So, you know, he thinks you should take it on the road.
I just put into chat almost all of the Q&A in detail. So for folks interested, if you just copy the chat before the meeting ends, you can have the full information of chats and Q&A. And the way you copy is go to, well, I'm not sure in this. Normally you go to the 3 dots in the right bottom corner.
I don't see 3 dots, so I'm just going to copy and paste, I think.
Okay, copy and paste into Word document or whatever locally, that would work.
Thank you for doing that. And, oh, do you want to put,
Yeah, I have a 28-minute YouTube video that is done by a professional who has a business in remediating HVAC problems in houses, and he's put out a whole bunch of different YouTube videos and web pages. I'm going to play a 2-minute summary of the 28 minutes at the conclusion of this. If you want to stick around for another two minutes after we finish, you're going to find this 2-minute summary playing, or 2.5 minutes actually. Summarizes just about everything we've been talking about, but in 2.5 minutes. Is now the time, or are there more questions?
I think we're ready to wrap up. So why don't you go ahead and do that?
Okay.
Let's recap the residential heat pumps. So there are 2 types. There's ground source, also known as geothermal, but like we discussed, it's not actually geothermal. And there's air source. So that is where they're pulling their heat from. There's 2 different types of air source heat pumps. There are mini splits, which usually don't have ductwork attached to them. And there are standard splits, which are basically replacing an existing forced air system. So if you have central air, central heat, that's what we're talking about here. Within the standard splits, you can either do a hybrid, which is a heat pump on top of a furnace, or you can do heat pump only. This is an all-electric option, so if you're looking to move off of fossil fuels, this is what you want to look for, maybe a mini split, depending on what your house and your needs are. I'd like you to promise me now that you will never buy an air conditioner again. Every air conditioner should have a heat pump installed, and the main reason for this is comfort, like I mentioned earlier. So you want to have the capability to match what the house needs with what the HVAC system is putting out, and that is only possible with smaller capacity, which a heat pump can offer. So at a minimum, get a hybrid system. Don't ever buy an air conditioner again, get a heat pump. It's not a giant jump in cost between them. Oftentimes it's just hundreds of dollars. It might be $1,000. It's not a huge spread when you're looking at a full HVAC system. And The one thing you're going to get though is you're going to get pushback from installers. They're a little harder for them to put in because if they install it in the winter, they have to come back in the summer and check the refrigerant. So the freon that's inside the system, they need to check that those levels are correct. So it makes a little more work for them. So you will get some pushback on that, and that's unfortunate, but hopefully that will change as time moves on. But promise me you won't buy an air conditioner again. You will ask for, at a minimum, a hybrid, and hopefully a heat pump only if that fits your house, because that will provide some spectacular comfort if it's done well. So that's it, how heat pumps work and residential options. So
So thank you for joining us.
Yes, thank you,
Thank you,
everyone.
everybody.
And,
All
and
right.
thank all the panelists. You were just really fascinating.